Now, what are the sequence stratigraphic surfaces? As we discussed earlier, that sequence stratigraphic serves as a boundaries for the system tracts. So, sequence is divided into its building blocks, that is system tracts, on the basis of bounding surfaces which are called as sequence stratigraphic surfaces. In other words, sequence stratigraphic surfaces serve as a bounding boundaries for the system tracts. Now, what are then how sequence stratigraphic surfaces forms? They refers to the surfaces that form due to the rise and fall of sea level. Remember, we have discussed that the sequence, a single sequence, represent the deposition during one sea level cycle or during one sea level rise and fall. So in this rise and fall or in a sea level cycle, a number of changes occur. Sometimes there is maximum transgression or maximum rise, while at other time there is maximum fall. Sometimes there is a start of regression, while at other time there is end of regression. So these changes that occur within the sea level cycle, they result in the formation of sequence stratigraphic surfaces. As if sea level change occur, then the stratal pattern, the pattern of strata also changes. So these changes are indicated, or these changes within the sea level cycle then result in distinct sequence stratigraphic surfaces. And these surfaces then not only indicate the changes that occurred within the sea level cycle, but these surfaces are also used for the division of sequence into system tracts. Here you can see that a number of changes in depositional trend occur during a cycle of base level rise and fall. These changes in trend results in distinctive stratigraphic surfaces which can be used for the correlation and to define units in sequence stratigraphy. Each stratigraphy has one or more types of surfaces which are recognized and used for correlation and unit delineation. Sequence stratigraphic surfaces mark changes in stratal stacking pattern, that is progradational to retrogradational or agradational pattern and vice versa. Sequence stratigraphic surfaces can be conceptual horizons, they can be physical surfaces. By the conceptual horizons, we mean that along these surfaces there is no lithological contrast and the lithology remains the same. By the physical surfaces, we mean that there is lithological contrast, but what type of lithological contrast, or what is the physical appearance of such physical surface, that depends upon the outcrop exposure. Now, what are the examples of conceptual horizons and what are the examples of physical surfaces? Unconformable sequence stratigraphic surfaces typically have physical expression, while any conformable sequence stratigraphic surfaces may be conceptual horizon or an observable surface with physical attributes or physical features, and it depends on the local condition of deposition or preservation. It means that conformable sequence stratigraphic surfaces can be conceptual horizon and they can be observable surface with some physical features, but either conformable sequence stratigraphic surface will be conceptual horizon or it will be an physical surface. It depends upon the conditions of deposition or preservation at that time in which sequence stratigraphic surfaces are forming. There are many types, or 5, 6 to 7 types of sequence stratigraphic surfaces. Number first is